Alright lads, we're going to do this. This is one linear, one quadratic. It's a simultaneous equation. Get one letter on its own, we'll get x on its own. So 2x equals 1 plus 3y, and then divide 1 plus 3y divided by 2. Now that's the linear done, so you're going to sub it into the quadratic, so you're going to get x squared, we're not going to get x squared, we're going to get 1 plus 3y over 2 squared minus 2 times 1 plus 3y over 2 times y minus 3y squared equals minus 3. Okay, and what happens when we multiply this out? It's going to be 1 plus 3y multiplied by another 1 plus 3y, and when you multiply that out you'll get 1 plus 6y plus 9y squared. Remember to square at the bottom as well, because there's 2 of them on the bottom, 2 2's, and that's going to give us a 4. Okay, and then on the other one we're going to multiply the 2 by the y to get minus 2y, and then the 2y multiplies by minus 2y multiplies by that gives you minus 2y. Minus 2y by plus 3y is minus 6y squared. I'm keeping it over the 2 currently. Okay, and then we have our 3y squared and our minus 3. Now I'm going to give it a common denominator of 4. So I'm going to multiply the top by 2 and the bottom by 2 to get 4. I'm going to multiply the top by 4 and the bottom by 4 and the top by 4 and the bottom by 4. And what we should get now is 9y squared plus 6y plus 1 minus 4y minus 12y squared minus another 12y squared, and then that equals minus 12. Now I'm hopefully going to arrange this all over one side. I'm going to get minus 15y squared plus 2y, bring the minus 12 over to the 1. I think we're about to get a plus 13 here, and then multiply both sides by minus, and you get a 15y squared minus 2y minus 13. I'd be inclined to do the minus b formula. So minus b plus or minus the square root of b squared minus 4ac all over 2a. A equals 15, b equals minus 2, minus b equals plus 2, c equals minus 13, and you'll get 2 plus or minus the square root of minus 2 squared minus 4 times 15 times minus 13. And that's got to be all over 2 times 15. And when you throw all that at the calculator, you'll get 2 answers. You'll get y equals 1 or y equals minus 13 over 15. Okay, now we got to also find the x values, and the x value is 1 plus 3 times the y value over 2. So 1 plus 3 times 1 over 2 and 1 plus 3 times minus 13 over 15, all divided by 2. Just use your calculator for both of them, and when you use your calculator for both of them, what do we get? Okay, I'll do it now. So that's 4 over 2, which is 2, so x will equal 2. And then the other one, and then the next one is 1 plus 3 times minus 13 over 15, and then we're going to put that all over 2 as well. That's minus 4 over 5 for x as well. Okay, so that's 1a done. Now we're going to move on to 1b. Now, the way I do this is I'd say that one root is 5 times the other root. So what we're thinking here is, if one root is for example, b. One root is b, the other root would be 5b. Okay? And we can work backwards, and we can say that x minus b equals 0 is a factor. Oh, better knock off that. And then x minus 5b is also a factor. And we can multiply the two of these by each other, so x minus b and x minus 5b. And we can get the quadratic equation out, which is x squared minus 5bx minus bx plus 5b squared. And you're sort of looking at this and you say, well, this equation therefore is x squared minus 6bx plus 5b squared. And you're sort of looking at this equation and you're going, well, wait a minute, that looks like nothing like my one, because my one has a 4x squared on it. Well, what I'm going to do with this equation is I'm going to divide both sides by 4. And then what you'll find out is that it's x squared, because divide that by 4, divide that by 4, divide that by 4, and divide 0 by 4. Okay, and we're going to find the value of k. So it's x squared plus 3x, and then it's plus k over 4. And that will also equal 0. Now these two equations are the same as each other, okay, because they have the same roots. So I'm going to put the two of these equal to each other now. Okay, so I'm going to put the red one equal to the blue one. The red one represents an equation that one root is 5 times the other root. Now what we're going to do here is we're going to pair these off. 6bx equals 3x, so minus 6bx equals 3x. The x's cancel. B equals 3 divided by minus 6, which is minus a half. Okay, and then b is minus a half. Okay, now we know that k over 4 equals 5b squared. This implies that k equals 20b squared, and b, not a, x, b, so 20 times minus a half squared, and 20 times minus a half squared is 5. So k therefore equals 5. Okay, and that's a nice little way to do that. Find the range of values of k for which the equation has no real roots. Now remember, this is essentially a U-shaped equation. Okay, and a U-shaped equation usually has two roots, so root A and root B. But occasionally when the numbers align, it'll sometimes have no roots, where it doesn't hit the x-axis. And the way we test this is using the formula b squared minus 4ac. If it's less than 0, there's two distinct roots. It hits the axis twice. If it equals 0, it touches the axis once. And oof, totally got that wrong there. B squared minus 4ac. If it's bigger than 0, it has two distinct real roots. If it equals 0, it means that it has one root. Okay, and it touches the axis once. And if it's less than 0, this means that it has no real roots and it doesn't touch the axis at all. So what we're going to do here is we're going to do b squared minus 4ac. Okay, so we're going to do b squared minus 4ac less than 0. So the a value is 4, the b value is 12, and the k value, or the c value, is k. So it's going to be 12 squared minus 4 times k less than 0. 144 is smaller than 16k. 144 is less than 16k. 16k must be greater than 144. Divide by 16, and k must be greater than 9. Okay, let's keep going. Alright, the sum of arithmetic series is given by the following. Alright, so what we'll simply do here is we'll write down what S1, S2 and S3 is, just by subbing in the numbers. Okay, and you can do this on your table function really quickly. We go modes, calculator, we'll do, instead of n, we'll do x into 3x minus 4. Okay, and I'll start it. So S1 is minus 1, S2 is 4, and finally S3 is 15. Okay, now the deal is that S1 also equals T1. So we know that T1 equals minus 1. We know that S2 equals T1 plus T2, which is minus 1 plus T2 equals 4. This implies that T2 equals 5. And finally, S3 is minus 1. It's T1 plus T2 plus T3 is what S3 is. So it's going to be T1 plus 5 and then plus your T3, and that equals 15. And what's that? That's 4 plus T3 is 15. T3 must be 11. Okay, so therefore we now have that T3 is 11. Happy days. Find the nth term and verify that the series is arithmetic. No bother. It's an arithmetic sequence because it sort of says it up here. And the arithmetic sequence is a plus n minus 1 times d. The a value is minus 1 because the t1 is always the a value for arithmetic sequences. And we see that it jumps in gaps of 6. So the d value will be 6 because there's a gap of 6 from minus 1 to 5 is a gap of 6, and 5 to 11 is also a gap of 6. Okay, so it's going to be minus 1, and this is 6 here. So it's going to be 6n minus 6, and the general formula will be 6n minus 7. Now, the way to prove that a series is arithmetic is that the difference d will be the same for tn minus 1. So we're expecting the value to be 6, essentially, right? The gap should be 6, okay? So we're going to do tn minus 1. We already know what tn is. Tn is 6n minus 7, okay? Now the whole deal with tn minus 1 is basically t7 minus t6. That'll be a gap of 6. t2 minus t1, that's also a gap of 6. T100 minus T99 is also a gap of 6. Once it's any number and the number directly below it, the answer should always be 6. And we're going to show that the difference is independent of n. Okay? So here's what we're going to do. So, we're going to do tn minus 1. So we're going to replace n with n minus 1. So tn minus 1 is 6 times n minus 1 minus 7, which is 6n minus 6 minus 7, which is 6n minus 13. And as expected, when you multiply this out, the gap is 6. D equals 6 for all values of n, element n. Now n has to be a natural number. Remember, it's t1, t2, t3. There's no negative numbers there, okay? So series is arithmetic. Now, we've got a bit of complex numbers thrown in for our just to make things nice for us. Okay, so here's what we're going to do. That's T1, your T2, and your T3. Okay, and it's a geometric sequence. Now, if you remember what geometric sequence is, it'd be something like 2, 6, and 18. You see that there's a common number that you multiply by. And for geometric sequences, it's Tn is AR n minus 1. Okay, and A is the original term. So in this case, A would be 2, and the R value would be 3. But obviously, this is much harder than this because we got to figure out what is the common ratio. Now, in geometric sequences, for example, this one here, T1, T2, and T3. T3 divided by T2 gives you the ratio R. which is 3. Or t2 over t1 also gives you the common ratio, which is which is also 3, because it'd be 6 over 2, and this one would be 18 over 6. Okay, so using that knowledge we just have here, we're going to use these two formulas here to tell us information about the ratio. Okay, so here's the first thing we're going to do. T2 over T1, so 1 plus 5i divided by 2 minus 3i. Now remember, to get rid of the denominator, we want to prove the answer is minus 1 plus I. We need to multiply the bottom by the conjugates. The conjugate is you go to the middle of the complex number, that's the denominator, and you change the sign. So I'm going to multiply top and bottom by 2 plus 3i top and bottom. 2 plus 3i and 2 plus 3i. Now I'm going to multiply this out. Okay, so we're doing T2 over T1 equals that, and now we're going to multiply it out, and we're going to get what are we going to get? We're going to get 2. We're going to get 3i. We're going to get 10i. And we're going to get 15i squared, and 15i squared is minus 15. And then on the bottom, it's the difference of two squares, so it's going to be 4. Whatever, plus 6i minus 6i, they always cancel. And then it's going to be minus 9i squared, and I squared is minus 1, so minus 9 by minus 1 is plus 9. And what we're going to get here is 9 plus 4 is 13. And then we're going to get minus 13 and 13i on top as well. And then all the dividing both by 13, and you get minus 1 plus I. Right, that's your R value sorted. Right, and I'm just going to rub this out because I don't need it anymore. Now, I'm also going to use T3 over T2. And T3 over T2 is minus 6 plus Qi divided by T2, which is 1 plus 5i, is equal to minus 1 plus I. Now you have a choice here. You can multiply top and bottom by the conjugate if you want. That will also get you the correct answer. But the way I'm going to do it is I'm going to change multiplication, division on the left into multiplication on the right. Okay, and I find that this will be a quicker way of getting my answer where I want it to go. So that's going to be minus 1. That's going to be minus 5i. Minus 1 minus 5i plus 1i, and then plus 5i squared, and plus 5i squared, that's a minus 1 is minus 5, and as predicted we get the minus 6, and we also get minus 4i, and this means that qi must be the same as minus 4i, and therefore q equals minus 4. Happy days. Okay, now look guys, that's question 1 and 2. I'm going to pause it there and say